Hi everyone! Today you are going to take notes and learn about the final way to solve systems of linear equations, which is through elimination. So you're going to add your notes page to page 68 in your ISN, fold the notes page in half just like we did for the other two methods for solving systems of linear equations. You'll start by writing the steps down on the front, and then inside we will do two examples. So before we get started on the notes, let's take a look at what it means to add equations. So here I have two equations, or a system of linear equations. I have the equation 2x plus y equals 4 and the equation 2x minus y equals 0. If I were to add these equations together, what that means is that I would be adding all my like terms. So if you look over here to the right, I have my like terms lined up. Here are my x's, my y's, and my constants. So I'm going to add my like terms. 2x plus 2x gives me 4x. Positive y plus negative y is equal to 0, so my y's cancel. And 4 plus 0 is 4. So now I have 4x equals 4. I can now solve for x because my y is canceled. So if I divide 4 on both sides, I get x equals 1. This is going to lead us into how to solve a system of linear equations through elimination. Because this y value canceled, we were able to find the x value. Why don't you try the next one? So here I have two more equations. Think about what your result would be if you add those together. So in other words, combine your like terms, add your like terms together. I'll give you a second to think about it. Okay, let's see how you did. So if we have our two equations, 2x plus y equals 7, negative 2x plus y equals negative 1, and we start to combine our like terms, we will combine 2x and negative 2x, which is going to give us 0. 2x plus negative 2x is 0. It cancels. Y plus y combines to 2y. 7 plus negative 1 is 6. And then I can divide by 2 on both sides to figure out what y is. This is going to help you as we go through the notes on solving systems by elimination. So let's start with the front page of your notes, the steps. As usual, the steps may seem a little confusing now until we actually get to the example, so for now just get them written down. So step 1. Multiply, if necessary, one or both equations by a constant so at least one pair of like terms have opposite coefficients. Multiply, if necessary, one or both equations by a constant so at least one pair of like terms have opposite coefficients. So opposite coefficients is like what we saw in our previous questions when we added the equations together and your variables canceled. So for example, y and negative y are opposites. Their coefficients are 1 and negative 1, so they will add up to 0. 4 and negative 4, those are opposites. So if you have 4x and negative 4x, they will add together to make 0. So you want to have at least one pair of like terms to have opposite coefficients because ideally we want them to cancel. This may already be done for you, so you may be able to skip this step. Step 2. Add the equations to eliminate one of the variables. So you'll add those equations together like we did on the previous slide. One of your variables will cancel, and you'll be left with just one. Then you'll be able to solve for the remaining variable, figure out what x or y is. And we know that with systems of equations, once you know what one of the variables is, you can substitute that value into one of the original equations and solve. So get these steps recorded, and then we will move on to our examples. So example 1, solve the system by elimination. I put the steps over here so we can refer back to them as we go through the problem. So here are two equations, x plus 3y equals negative 2 and x minus 3y equals 16. So step 1 says to multiply, if necessary, one or both equations so that at least one pair of like terms have opposite coefficients. So let's go through and look at our variables. So here I have 1x and 1x. Those are not opposites, so they won't cancel. Here I have positive 3y and negative 3y. Well, these are opposite coefficients. So therefore, step 1 is already done for us. The coefficients of the y terms are already opposites. So we can move right to step 2. Step 2 tells us to add the equations to eliminate one of the variables. So here we go. If we add our equations together, we have x plus x, we have 3y plus negative 3y, and negative 2 plus 16. So that's going to give us 2x, our positive 3y and negative 3y cancel, and negative 2 plus 16 is 14. So now we can move on to step 3, where we solve for the remaining variable. So in this case, that is x because the y is canceled. So if you were to solve for x, 2x equals 14, divide by 2 on both sides. Scroll down a little. And we get that x is 7. So now we can move on to step 4. We can substitute that 7 into one of the original equations to figure out what y is. Okay, so here's step 4. Substitute 7 for x in one of the original equations and solve for y. Remember, it doesn't matter which equation you plug in for, you should get the same answer. So I chose to plug 7 into the equation x plus 3y equals negative 2. So 7 is our x value, so when we plug that in, we will get 7 plus 3y equals negative 2. Now we need to solve for y. So we will subtract 7 on both sides, which gives us 3y equals negative 9. Divide by 3 on both sides, and y equals 3. Negative 3, excuse me. Y equals negative 3. So our final answer, we can say the solution is 7, negative 3. 7 was our x value, negative 3 was our y value. And as with all systems, you should be plugging those back in to make sure that that is correct. Let's take a look at the second example. So again, we're going to solve the system by elimination. We have our two equations up here, negative 6x plus 5y equals 25, negative 2x minus 4y equals 14. So I'm looking to see if I have opposite coefficients for any of my terms. So here I have negative 6 and negative 2. Those are my coefficients for my x values. They are not opposites. Let's look at the y values. Positive 5 and negative 4. Those are also not opposites. So what we're going to need to do is multiply an entire equation by a constant in order to make one of our terms opposites. So in this case, we're going to multiply equation 2 by negative 3. I don't know why it's not lighting up. Well, you can kind of see it. So we're going to multiply equation 2 by negative 3 to get a pair of like terms with opposite coefficients. When I do that, when I multiply negative 2 by negative 3, that will give me positive 6. And then my negative 6x and my positive 6x will be opposites. So let's take a look at how we do that. So I have to multiply both sides of the equation by negative 3. Remember, as with any equations, to keep it balanced, you have to do the same thing to both sides. So on our left, we're going to multiply negative 3 by negative 2x, and we're also going to multiply negative 3 by negative 4y, so we're using the distributive property. So negative 3 times negative 2x is 6x, negative 3 times negative 4y is positive 12y, and then on our right side, negative 3 times 14 is negative 42. So now I can add my equations. Now I have a pair of opposite coefficients. So here's my new equation 2. Here's equation 1 in black, equation 2 in blue. So now I can go ahead and add them. So negative 6x plus 6x will cancel. 5y plus 12y is going to be 17y, and 25 and negative 42 is negative 17. So I'm left with 17y equals negative 17. I can go ahead and solve for y here. Divide both sides by 17, and I get that y is equal to negative 1. Now I know my y value. I can move on to step number 4, and I can plug in my y value to one of my original equations to find x. So again, you can plug into either equation. I have chosen to substitute. Again, I don't know why it's not working, but that should be a negative 1, so write negative 1 here. I'm going to substitute negative 1 for y in the second equation I chose to use. You can use either. So negative 2x minus 4y equals 14. My negative 1 is my y value, so when I fill it in, I have negative 2x minus 4 times negative 1 equals 14. Negative 2x plus negative 4 times negative 1 is 4, so negative 2x plus 4 is 14. Subtract 4 on both sides. Now I have negative 2x equals 10. Divide by negative 2 on both sides, and we get that x is negative 5. So the solution to the system is negative 5, negative 1. And we can go ahead and substitute these values back into our original equations to check. So if you missed anything during the notes, rewind the video, watch it again. The final thing I want you to do is on the left-hand page, page 67 in your ISN, I want you to answer these 3 questions based on what you just learned. So question number 1, what has to be true for at least one pair of like terms for you to use the elimination method to solve? So we can't use the elimination method until you make this true. So go back, hint, hint, refer to step number 1. Okay. Question number 2, oops, little typo. So question number 2, there we go. Why is step 1 only needed if necessary? So in other words, sometimes you don't need to do step 1. When would that happen? Why would you not always need to complete step 1? And finally, question 3, how is solving systems by elimination similar to solving systems by substitution? So what are you doing in both methods? What is the same about them? So answer these 3 questions on page 67. We will review them on Monday, and then we will do some practice. Thanks.